Hello guys, this video is for pre-cal week 8, Wednesday and Thursday on 7.2 series. Okay, so last time we did sequences and now we're on series. And let me just review real quick. Sequence, a random sequence, or something that we learned last time. It can be like 2, 4, 8, dot, 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 and 2 to the 48, 2 to the 49, 2 to the 50, and just like this can be a sequence, okay? And then if I'm talking about series, it can be the same thing, except it's not going to be comma, and it's going to be plus signs. We're adding, and then there are numbers in between. So a series is adding up all the numbers that are from a sequence. So if I'm talking about arithmetic series, that is the sum obtained by adding up the terms of an arithmetic sequence. Okay, so let me show you an example real quick. So if I want to add up, so they would tell you to evaluate 101 plus 102 plus 103 plus dot 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 plus 198, 199, and 200. Okay, if you have to add up all of those numbers, you don't want to use your calculator because sometimes you may forget a number. So that's why there's something called series that in math are created. And I'm going to show you a trick on how to find the sum, and then this trick will turn into a formula, which is really easy to use in a little bit. Okay, so I'm gonna first let S equal to the sum of all the numbers. Okay, and then I will write S equal 101 plus 102 plus 103 plus dot 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 plus 198 plus 199 plus 200. Okay, and then I'm gonna write S again. This time I'm gonna write it in reverse order. So that means I'm gonna start with 200 plus 199 plus 198 plus dot 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 plus 103 plus 102 and plus 101. Okay, and then I'm actually gonna find the sum of these numbers, like from top to bottom. S plus S is gonna be 2S equal to what happened if I add up these numbers together? It's going to turn into 301, and then add up these two numbers. We get 301, 301 plus dot dot dot, and all of those are still 301. Okay, so you would notice that these numbers that I'm adding up, they're all turning into 301. And how many of these 301s do you think we have? We have 100 of them because we have 100 numbers in here. From 101 all the way to 200, that is 100 numbers involved. So I'm going to write 100. Again, this is the number of terms. Okay, and we equal it to 2s. And our job is to solve for s. So we can divide by 2. So we have s equals to 301 times, these can get canceled out, make it 50. So put it in the calculator, you get 15,050. So that means if you are gonna you have time and add up all those numbers up here, you get 15,050. Okay, so here's the formula where I'm going to show on the next page. Formula for arithmetic series. Okay, which is S equal N times F plus L over 2. And F is your first number, L is your last number, and N is the number of terms, however many numbers we have. And S, of course, is series. Okay, so from here, I'm going to show you a proof on how this formula is created. If you're interested, you can watch this. If you are not interested, then you can skip a little bit. So I'm gonna write proof. So same thing, if I have S equal to the series, I'm gonna be using only letters, not like examples. I'm only gonna be using letters and like just the F and the L and the N to show you how this formula is created. So I'm going to use the first number and the last number, right? And the next number, F, we have to be adding D. D is our difference. Like, how do you get to the next term? That pattern is D. Plus F plus 2D, because I have two of those. Okay? Actually, I'm going to move this till the end. Plus dot dot dot, plus, now we're going to go backward because we have L. So right here would be L minus D. And then if I subtract another D, would be L minus 2D. Okay, and then eventually you're going to, have all those numbers. And then if I'm going to do another one where S equal to the reverse of this, it will be L and F. And this would be L minus D, L minus 2D, plus dot dot dot, plus F plus 2D, and F plus D. Okay, and then now I'm gonna combine these numbers together. S plus S is 2S equal this first part, we get F plus L, and then we drop our plus sign. And then what does this give you? D and D actually cross off, we get F plus L. And then the next term, we cross out these again, we get F plus L, and dot dot dot, we get F plus L also, F plus L, and F plus L. Okay, and F plus L, we have a lot of them, and it really depends on how many numbers we have, which is in this case N, equals to 2S. And then we divide by 2, so S equals to N times F plus L over 2. That's how our formula is created. Okay, so I'm done with the proof, and now I'm going to show some example. Let's do 2 examples. So example 1, actually I'm going to do 1 example and 1 is your homework problem. So let's look at 3 plus 8 plus 13 plus 18 plus dot 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 plus 103 plus 1003 and 1008. Okay, so from 3 to 1008, If I'm skipping number like this, I actually don't know how many numbers there are. So first off, we have to check, this is really important step, check how many terms there are in this sequence. Okay, and to check how many terms we have, we're gonna go back to use our formula from last time, which is a sub n equals to a sub 1 plus d times n minus 1. Okay, and I noticed that we have our first term as 3 plus, what's our pattern? Pattern is adding by 5, right? So it's 5 times n minus 1. And our last term, because if we go all the way to here, that's 1008. And then my job is to solve for n. So I'm going to minus 3 on both sides. 1005 equals to 5 n minus 1. Divide by 5. That is 201 equals to n minus 1. So n equals to 202. Okay, so I have my n ready. Looking at my formula, I have n equals to 202. I need f and l, and then I can substitute everything to my function. First number is 3, last number is 108. Okay, so substitute everything in the function. We have s equal 202 times 3 plus 108 over 2. And if you put this in your calculator, you should have gotten 102,111. That's the sum of all those numbers from 3 to 108, skipping by 5. Okay. One more example, which is your homework question. I'm going to show number 6. So number 6 is 300 plus 293 plus 286 plus dot 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 plus 55 plus 48 plus 41. Okay, again, these numbers, it's hard for me to know how many numbers are in between, so I have to check with the formula how many numbers. First off, how's the pattern like? How do we go from 300 to 293? That's adding a negative 7. And does that apply to the next one? Yes, it's still adding a negative 7. So I'm going to go ahead and check how many terms we have. I'm going to check it right here. Check number of terms. And using our formula, it's 41, because that's the last number, equals to our first number is 300, adding our negative 7 times n minus 1. Okay, move your 300 over to the other side. We get negative 259 equals to negative 7n minus 1. And if you do the math, n would equal to 38. Okay, so we have our n ready, f and l ready, because they are 341. Okay, substitute everything in the formula. We have s equals 38 times first and last number, which is 341 all over 2. Okay, and your final answer, you should get 6,479. Okay, so that's it for arithmetic series. We're gonna go into the next one, which is geometric series. Okay, so geometric series, it's still the sum obtained by adding up the terms of a now this time is geometric sequence. Okay, so if you remember last section, a geometric sequence is something that we multiply to get the same, exactly the same number to get to the next number. So look at this series. We are going from 139 all the way and 3 to the 47, 3 to the 48, 3 to the 49, like this. Okay, so this is an example of a geometric series. The pattern here is multiplying by 3. Okay, still applies. We're still multiplying by 3 to get to the next number. And now they would ask you to evaluate this. How do I add up all of these numbers together? Okay, as you would know, if I really have to add them all up, it's going to turn into a very overflow number in the calculator. So in that case, once you substitute it into the formula, you can technically leave it. Okay, but I'm going to start talking about how do we find this series using the trick again. Okay, again, this trick that I'm going to go over is going to lead to the formula. Okay, I'm still going to let S equal to the original formula. Original series. 3 to the 49. Okay, this time I'm not going to write it in reverse because there's no point of writing it in reverse. We're not adding. What we're going to do is we're going to multiply by what the ratio is, like what the pattern is. In our case, our ratio is 3. We are multiplying by 3, right? So I'm going to multiply my series by 3. If I multiply by 3 to the first number, which is 1 right here, is going to be 3. If I multiply to the next number, it's going to be 9. If I multiply to the next number, it's going to be 27. So I'm going to be writing this skipping a space. And it will be 3, 9, 27, which I'm not going to write, and then dot, dot, dot. And if I multiply 3 to the number before this, it's going to give me 3 to the 47, 3 to the 48, 3 to the 49. And if I multiply 3 to the last term, it's going to be 3 to the 50. Okay? What I just did here was that I moved the whole entire series one number to the right and created a new number. Okay? So I'm going to be, instead of adding it up, I'm going to be subtracting. Subtract from the bigger number to the smaller number for both sides, both of these. Okay, so subtract 3s and s is going to give me 2s. And then if I subtract, you would notice that everything in the middle got canceled out. 3 minus 3, 9 minus 9, and everything in between would go away. These are all going to go away. And then I'm going to be left with 3 to the 50. And then this has a zero power, right? I mean, zero number, right? So 0 minus 1 would be negative 1. Okay? And then we're just going to divide by 2. And that's it. S equals to 3 to the 50 minus 1 over 2. I am not going to put this in the calculator because I know it will say overflow. And now I'm going to write the formula, which is really similar to that. It's going to be S equal B times 1 minus R to the nth power all over 1 minus R. Sorry. And B, in this case, is going to be our first term. And then R is our ratio, which is pattern. And our n is number of terms. Okay, again, the next part, I'm going to show the proof on how this formula is created. If you're interested, you can keep watching. If not, you can skip a little bit and go on to the examples. So proof of this formula, we are given a series S equals B plus, to get to the next number, if I have to multiply by R, it will be B times R, right? And then if I have to multiply another R to this, it will be BR squared plus dot 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 plus, and then we are going to, oops, go from BR to the n minus 2 plus BR to the n minus 1. Okay, let's say this is a series that we get. And if I have to multiply this whole entire series by R times S, then we're still going to have B times R, which is BR, plus BR squared plus dot 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 plus BRN minus 2 plus BRN minus 1 plus the last number, which is like up here, which is the 3 to the 50. It's going to be B to the n power. Okay? And then we're going to find what happened when I subtract them. If I subtract them, I get RS minus S equals to, all of these get canceled out. We get B to the n minus B. Okay? And then, actually, I'm going to write it as negative B plus B to the n, which is the same thing. But it's going to kind of match our formula up there. Okay? And then with what we have, we're going to try to solve for S from here. Look at the left side. We have S in both of these terms. So I can actually factor out an S, which we get R minus 1 equals to negative, oh, they actually also have B in common. So I'm going to factor out negative B, which is going to give me 1 minus B, wait, hold up. B, oh, it's BRN. Oops, right here. This is BRN. So right here, I'm sorry, it would be BR to the nth power. Okay, now it makes more sense. And if I take out a B, I get 1 minus R to the n power. Okay, and then I just need to divide both sides by R minus 1. Then I have S equals negative B times 1 minus R to the nth power all over the bottom part. If I take out a negative, it would be 1 minus R. So these negatives goes away. I have B times 1 minus R to the nth power all over 1 minus R, which is the formula up here. Okay, now I'm going to go over the examples. I'm going to write the formula, oops, one more time, so you guys can refer to this. Okay, let's look at number 23, for example. I have 1 over 4, 1 over 16, 1 over 64, plus 1 over 4 to the 50 power. Okay, so what do you think? What do you think our pattern is? Because we kind of have to know our pattern. How do we go from 1/4 to 1/16? We multiply by 1/4. Multiply by 1/4. Okay, because we multiply by 1/4, our ratio, which is R, is going to be 1/4. Okay, And then our B is our first term, which is 1/4 also. And how many numbers are there? We have 50 number because it went from 4 to the second power, 4 to the third power, all the way to 4 to the 50. So it'll be 50 right here. Okay, let me do some color coding. This is from here, and this one right here is right there, first number. And since we have all the numbers, we can just fill out our formula. Oops. S equal first number, which is 1/4, times 1 minus 1/4 to the 50th power, and then 1 minus 1/4. Okay? As long as you can substitute in everything, you can leave this as your answer. But those of you who want to continue, this is going to turn into 1/4 times 1 minus 50 is going to go into each of these exponents. So 1 to the anything is 1/4 to the 50. And then at the bottom is going to turn into 3/4. Okay, so our top 1 times the top is still going to be 1 minus 1/4 to the 50th power, all over 4 and the 4 get canceled out, so it'll be 3. This is our final answer. Okay, so that is one of the questions. And the last thing I'm going to go over, because some of your homework question, you're going to see the symbol right here. Okay, and this symbol, it's sigma notation. Okay, so I'm going to give an example. You will see a number on top of this E looking thing, and then have K equal, or a letter equal to a number, and then the function. Okay, so real quick on the side, I'm going to explain what this is. So this symbol right here, it's sigma, which stands for summation notation. We're finding the sum of something. And in this case, with the E and the 1 and the 99 and the K square, this is read as the sum as K goes from 1 to 99 of K square. Okay, the bottom number right here, it's the first number that we're going to plug it in. And this is going to be the last number. We're going to plug it in, finding the sum of the whole thing. So I'm going to put it equals to, put 1 into K, it'll be 1 square plus 2 square plus 3 square plus dot 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 all the way to 98 square plus 99 square. And you stop right there. Okay? And then from there, you're supposed to find your sigma and go on from there. Okay? I'm going to do one of your homework questions. That's the last thing we're going to do. I'm going to do number 28. You will see a question that looks like this. So the sum as K goes from 1 to 90 of 5 over 7 to the K power. Okay? Not only we have to rewrite it the whole thing, we also need to find the formula from there and actually find the series from there. This equals to 5 over 7 to the first power plus 5 to the 7 to the second power, 5 over 7 to the third power, dot, 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 all the way to the last one, which is 5 over 7 to the 90th power. Okay, and still, we have to find, according to our formula up here, we have to find what the B is, R is, and N is. B is our first number, which is 5 over 7. And R, how do I go from 1 to the next number? Go from here to here. The top doesn't change at all, which is 1. over the bottom. We keep multiplying by 7, so it's 1 over 7. So right here, this is r equals to 1 over 7. And then from 1 to 90, how many numbers are in between? We have 90 numbers in between. Okay, so let's use this and figure out our final answer. S equal 5 over 7 times 1 minus 1 over 7 to the 90th power, all over 1 minus 1 over 7. Okay, I'm going to keep solving for this. We have 5 over 7 times 1 minus 90 to the first is just 1, and then 7 to the 90, and then we have 6 over 7. 7 and the 7 get canceled out. We have 5 going into each of these. 5 minus 5 over 7 to the 90, all over 6, because the bottom get canceled out. Okay, you can leave your answer as, right at the beginning, or if you want to go ahead and solve for everything, you can do that too. Okay, so your homework is right here. For Friday, no, actually, sorry, for Wednesday, your homework is 1 to 10 even, and then Thursday is 21 to 30 even. And I think I just did one of these questions for you. And this one right here. Okay, so that's it for this